Hello, dear students. I am Professor Mayuri Patel from Technocrats Group of Institutes, Civil Engineering Department. Today, we'll be studying about the subject Basic Civil Engineering and Mechanics for our first students. The topic for today's discussion is building stones and bricks. Initially, I would be starting with stones. Stones introduction, classification, test on stone, and the properties of good building stones. Stones, if we go ethically, definition wise, the stones are nothing but the naturally occurring compact, solid, and massive material that come make the crust of the earth. Technically, we refer stones as rocks. The rocks occur in different varieties of having different properties and are basically used as the building block materials or as in the aggregate forms in for construction works. Stones are used for the construction in ancient times. The fine architectures which we can observe using stone in construction are the Temple of Jagannath Puri, pyramids of Egypt, the Eiffel Tower, temples throughout the country, for example, Orcha, South in the South India, the Sun Temple, etc. Stone, timber, and clay had been the most commonly construction used material right from the beginning of civilization till the advent of Portland cement. Hence, we have live proofs which we can observe uh, everywhere which prove that the stones are far much stronger material which are used as a building blocks since the olden ancient periods. Initially, in the start of the topic of stones, we'll be discussing about the classification of stones. What are different types of stones? Depending upon their origin, their formations, or the chemical contents. Broadly, we have three classifications, as here you can see on your screen. The first one is your geological classification. Your geo means earth surface. So where do they come on the earth surface? How they are formed? This would be a first classification. The second one is your physical classification, which tells me about the physics of your stone, means how the stones are in their formation when we break them or their shape basically. The third one is about the chemical content, the major chemical content present in the stones. So let us now discuss about the first classification of stone, that is geological classification. The classification based on the mode of formation of rock from which the building stones are obtained. Depending upon the origin basically or depending upon the mode of the occurrence, there are three classification based on the geology. The very first one is igneous, the second is sedimentary, and the third one is metamorphic rock. What is igneous basically? Is ignis is a word which relates to fire in Greek. So basically how where the fire or high temperature material comes on earth's surface, that is due to earthquake or their volcanic eruption. So the igneous rocks are nothing but the rocks which are formed from the molten magma solidification which comes on the earth's surface after or during the earthquakes or during the volcanic eruption. All of us know that during the earthquakes or during volcanic eruption, the temperature of soil mass is very high. We get a liquid or semi-liquid type form of a material that comes on the earth's surface, which we call as lava or magma. After it cools down, after it solidifies, it takes a formation of a hard rock, and that rock is nothing but a igneous rock. So igneous rocks are what? These are the rocks which are basically the formation formed after the solidification of molten magma or lava which comes on the earth's surface due to the earthquake or the volcanic eruption. The second type of the geological classification of rocks or stones is sedimentary rocks. Your sediment means particle. All of us know that due to the action of heavy water or wind, the soil particles may transfer from one place to the other. What happens exactly is due to this movement of particles from one place to the other, they travel along with wind and water and settle down at certain place, which where they upon which more and more layers come over decades and decades. And you may observe that after decades, a huge rock, a strong rock mass is being formed from these fine sediments or particles, which have traveled all the way due to the influence of water or wind, and such type of rock formed through different particles is called as your sedimentary rock. The third one is your metamorphic rock. Here again a new word for all of you: meta and morphism. Meta means change, morph means form. When there is a change in form of the original rock, a new rock is formed, and that new rock is called as a metamorphic rock. What it means? Initially, the rock is either sedimentary or igneous, but due to the environmental changes, chemical changes in the environment, which may relate to the chemical constituents or due to temperature changes in the environment, the rock which was originally an igneous or sedimentary, due to all these changes over decades, it has changed into a new rock. We get a new rock with new properties and new form, and that newly formed rock is called as your metamorphic type of rock. So these are the three classification based upon the geological classification: igneous rock, sedimentary rock, and metamorphic rock. Nextly, we have the chemical classification. All of you have studied chemistry and may relate to this particular classification. Every material on Earth's surface consists of different types of chemicals into it. Similarly, broadly, the rocks are classified into three major classification or three major types depending upon their major content, major chemical present into it. The first one is siliceous rock. These rocks have silica as predominant component, means yeah, more than 50% of its constitute of silica. Hence, it is known as what? Siliceous rocks. The second one is your calcareous rock. In this particular rock, we have calcium carbonate in maximum quantity. Hence, such rocks are called as what? Calcareous rocks. The third one are the argillaceous rock. Here, argil is a new word. Argil means clay. So the rocks which majorly have clay content into it are called as what? Argillaceous type of rocks. Siliceous have more quantity of silica, calcareous have more quantity of carbonates, and argillaceous have more quantity of argil, that is clay, into it. These are my chemical classification of rocks. Nextly, we have structural classification. What does exactly structure means? Structure means the formation or shape or the variation which we have in their forms. Based upon it, we have three classification. Majorly, we'll be discussing the two amongst them, that is stratified and unstratified rocks. Yes, stratification means what? Stratification means layer. I would like to give a very day-to-day life example over here. All of us eat chocolates. We are fond of chocolates. So what exactly is a stratification? Stratification means layering. The way we have layers in one of the chocolates such as Kit Kat. We have layers. Whenever I break Kit Kat or Munch, I get different layers. Means what? Munch has different stratification layers. Okay, so the type of rocks which have layers into it, if I cut them out, I would get different plane surfaces of weaker strength maybe, but when we break them, we get different layers. That means the rock can be separated in different layers, thin layers. Such type of rock are called as stratified rocks. Just opposite to it are the unstratified one. Unstratified rocks are those which, upon breaking, don't give layers. We get fine particles into it. These are the solid rocks made up from fine grained particles. Means what? Small size particles. The rock formed from the particles basically is a unstratified rock, or also known as a massive type of rock. So if you want to remember in exams, you may remember dairy milk versus your munch. Dairy milk has fine particles. We don't get layers upon its breaking. Hence it is called unstratified. Whereas munch, when break, we may get layers into it. Hence it is called as what? Stratified type of rock. The another important concept which you need to remember during the studying of stone, this is dressing. What exactly is dressing? If for a moment I forget about engineering, dressing means to get ready. When all of you go to your college, you get ready, well ready, and then you sit into your classroom. Similarly, it may happen. All of us know that we get stone is a naturally occurring material basically. We may get it from the quarry. It may have different shapes, weird shapes. But if I cut the stones as per as my requirement, if I give the stones a shape and size as per as my requirement, and then I use it, such stones are called as dressed stones. Hence, dressing of stones is nothing but a process to give proper shape and size, proper finishing to the stone as per as your requirement. The dressing may be done either manually or mechanically or by using the combination of both the methods. Here on the screen, there are different types of tests which are conducted on stones to find out its different properties. One, so the hardness test, crushing strength test, impact test, fire resistance, attrition, acid test, crystallization test, microscopic freezing, thawing, etc. Amongst which we are going to discuss one or two here. The very first test is the crushing strength test. Strength is nothing but a capacity to bear the load. How much load would be taken by my stone? So what are we going to do in this particular experiment is, I would cut a small cube of stone of the size 40 by 40 by 40 mm from the parent stone. Here the parent stone is the original stone from which I am going to cut out my cube of required size. This cube is properly finished all its sizes, means it is made up of equal plane surfaces. It is either covered with a thin layer of POP, that is plaster of Paris, to make all the surfaces plane or equal, so that when we apply load, it transfers equally on all the surfaces. Or I may keep two thin plywood sheets, one at the bottom and one at the above the top surface of the stone, so that when I apply load, it may come down in equal proportion. Then the ready stone is placed in the CTA machine, where we apply load at the rate of 40 Newton per mm square per minute. A point would come after starting the machine where I would observe crushing of my stone or cracks in my stone. That is the important point. Then I'll stop my machine. I'll get the maximum load taken by the stone, beyond which it is breaking, and that load is known as a crushing load. I know the area of my block which I have placed in the machine, so this crushing load divided by area would give me the compressive strength or the crushing strength for which this test has been done. Second and the important one of the most important test is impact test. Here the machine which I use is impact testing machine. Basically, as you can see here in the diagram, it consists of a falling hammer. For how this test is concerned. For this particular test, I take the stone aggregate sample. I placed it in 3 equal layers in a cylindrical mold. After each layer, I tamp it with a tamping rod so that all the air voids are removed. Then the second layer, then the third layer. After each filling layer, I would tamp the material so that maximum material gets compacted in my mold. From that particular mold, I'll take a small known weight of sample in a bowl, which would be placed here at this position, the impact testing machine. While filling this small cup of stones or aggregates, it is again tamped to remove all the air voids so that maximum material gets filled into it. After placing here, it below the hammer, this is the hammer. We drop it from the height of 48 or 380 mm, that is 38 centimeter to 48 centimeter, and we get equal again we get impact on the aggregate. After giving the number of blows or number of drop downs on the particular aggregate mold, we would observe that we would remove the amount of sample. Initial weight is known to us. The weight after the hammering, or you can say after the impact given to the material is being can be calculated, and from these two values I may get the amount of material which has crushed over here. So here I'll be getting the impact value test. Next is my water absorption test. For this, I may get, it is a very simple one. Initially, I'll take a stone sample whose weight would be taken as W1. Then the cube is immersed in water for 24 hours. After removal and cleaning its surface, I'll take its weight as W2. So the percentage of water absorption after 24 hours would be W2 minus W1 by W1 into 100. If I want to calculate the porosity by volume, it would go to the as the formula is shown on your screen, that is W4 minus W1. Here W4 is nothing but the weight taken when I've boiled the stone in the water for few hours. Similarly, from the formula, I can get the saturation coefficient, which is water absorption divided by total porosity also. Lastly, we'll be discussing about the acid test. Acid test basically is to find out the amount of free lime or unburnt lime in your or the lime content in your stone. More the lime content, more the chances of efflorescence, less would be the strength. For this particular test, a stone is kept in for 1 week in a solution of 1% of sulfuric or hydrochloric acid. During this 1 week or during this 7 days, the solution is stirred once a day. After the 7 days time span and removal of the stone from the solution, if the edges and the surface of the stones are as we have placed them, it means we have no lime present in the stone and it is good enough. Otherwise, if its layer edges are been broken and we get a thin layer of fine particles on the solution, it means there is more lime content which may exhibit efflorescence when subjected to the action of acids. Lastly, we have uses of stones. Stones, as I discussed initially, they can be used for the construction of foundations, walls, columns, for the flooring works, for roofing works, for waterproofing works, in the construction of abutments or piers. Uh, Here the word abutment and piers means the heavy columns of your bridges, dams, retaining walls, etc. Crushed stones are used in the form of aggregates for the base work layer for roads. In case of railway line, they are used as the ballast. They can also use to protect the metal columns. They are also used to give a lining that is covering to the areas where high degree temperature works have been done, such as furnaces, etc. These are few of the qualities of good building stone. In the very first one is crushing strength. For a good structural stone, the crushing strength should be greater than 100 Newton per mm square. It should have good facing appearance. Facing here means the front portion, so that it may impart a good look to my structure. It should be of uniform color and free from any type of clays, holes, spots, or any other bands, etc. Discussing about the qualities of good building stone, the very first one is its crushing strength. For a good structural stone, the crushing strength should be greater than 100 Newton per mm square. If we go, as I've said earlier also, that it should be good in its appearance, it should have uniform color, it should not have any type of flaws. Its coefficient of hardness should be greater than 17. For a good stone, the percentage of water absorption should also be minimum. The stone should be tough enough to bear the impact or sudden load coming onto it. More the specific gravity of stone, more heavier the stones are, and more stronger the stone are. Nextly, the second most important material which we are going to discuss in this particular session is bricks. In the bricks topic, I would be discussing about the introduction, means what exactly brick is, what are its standard sizes, its requirement, its method of construction, element, that is what are its components. Nextly, the qualities of bricks and the test on bricks. As you can see the diagram of bricks, and many times you have already seen, I suppose, brick is nothing but it is an artificially built rectangular block material used for building construction or used in the pavements or other type of construction works. Basically, there are two types of bricks, modular brick and the traditional bricks. We'll be discussing about modular bricks, which are widely used everywhere for the construction. I would like to discuss about the components or elements of bricks here. Looking at the diagram, you can see it is cuboid or rectangular in shape. It is having sharp edges or corners. The brick's standard size is 19 by 9 by 9 centimeter. If I go into mm, it is 190 by 90 by 90 mm. The longer span of the brick, here where the arrow is shown in your figure, this is called as the stretcher portion. This smaller area is called as the header one, and the hole on the brick which we have here where the ABC is being written, it is called as a frog. Frog is nothing but it is a depression or a mark break made on the brick. They basically two purpose of providing frog. The first one is it is provided to provide a key or a surface or a place where the mortar can be filled to create bond. What bond? To create joints. When we construct a wall, basically the two bricks are stuck to each other. We need a certain binding material, that is mortar, a cement paste. So due to this presence of this frog, extra mortar can be filled, which may create a proper bond with the upper or the lower bricks. And the second important function or the purpose to provide the frog is to give a space for the manufacturer to draw its or mark its logo or its name. Now let us discuss about the qualities of good brick or the properties of brick, how we are going to check them out. The very first one is the brick should be a proper shape, proper deep red or cherish color. All its edges should be sharp enough. There should be no breaking or coming out of the particles. There should be no white spots onto it. Any type of spots into it. There should be no flaws into it. When we immerse the brick in water for 24 hours, it should not absorb water more than its 1/5 of its own weight. The compressive strength of brick is generally 15 to 35 megapascal. Whenever I scratch the brick with my fingernails, there should be no marks present onto the bricks after my scratching, which would show that the brick is sufficiently hard. When I drop down the brick from a height of 1 meter, it should not break into pieces. If it is so, that it means the brick is of good strength. If it breaks down, it means it is not having sufficient strength. There should be no white spots. As you can see here in this diagram, the white spots are being developed on the brick surface. This effect is known as efflorescence effect. Efflorescence is nothing but the reaction of free lime with water. I'll be discussing later on during the testing section. The brick should be non-inflammable. It means it should not catch fire. It should be incombustible. It should not burst. They should be free from lime pitting. When two bricks are struck with each other, they should create a metallic sound. The brick should neither be overburnt nor be underburnt. Discussing about manufacturing bricks, it basically consists of three main steps. The very first one is preparation of clay. Second is your molding. Third, which may also include molding and drying. And the last one is burning. So burning means what? The molded clay is being heated so that it gets hard enough and it gets its strength. So, but the burning should be done in proper amount. It should neither be more, it should neither be less, because the underburnt bricks would not give us more durability. They would break down, they would not take more load, and the overburnt bricks may also be of a weaker strength and weaker properties. The few tests conducted on the bricks are compressive strength, water absorption test, efflorescence test, hardness test, soundness test, structure and dimensional tolerance. Let us discuss about the very first test and the simplest test, that is known as a water absorption test. For this particular test, I take a few sample bricks from the stock which I have, and I measure its weight. The initial weight here I am taking it as M1. I would immerse the brick in water for 24 hours. After 24 hours, I'll remove the brick, clean its surface, and again weigh it as M2. The difference now, the amount of water absorbed is equal to M2 minus M1 by M1 into 100. The second test is the compressive strength test. Here again, we would be doing the same process as we did for the stones. We would prepare this brick here. In case of stone, we made a cube, but here already a brick is of standard size. We don't need to make a cube. Yes, sorry. We need to fill the frog because it is a gap. We need a plain surface so that we get a uniform load onto the surface of which we have put for testing. So we need to fill the frog portion with mortar so that a plain surface would be created on which the load is applied to the UTM or the CTM machine. The amount of load or the reading of load where we get the crushing cracks on your brick surface, that is known as the crushing load, or the maximum load at failure. The maximum load at failure divided by loaded area of the brick gives me the compressive strength or the crushing strength of my brick. Nextly, we would be discussing about the classification of bricks based on their quality. The bricks used in construction are classified as first class bricks, second class, third class and fourth class depending upon their quality. The very first one are first class bricks which have all standard properties: good color, soundness, hardness, no scratching, no types of flaws and everything. The properties are desirable or up to the mark. The second class bricks are ground molded. They are built in curls. The edges may not be as sharp as my first class bricks, but rest of the properties are same. They are commonly used for the construction of walls which are going to be plastered. As all its properties are good enough, but regarding its edges, they can be covered up with the plastering. Hence, they are used in the permanent structures. The third class bricks are ground molded and burned in clamps. Their edges are somewhat distorted. They are not proper edges. They don't give me a good sound. They give me a dull sound when stuck with each other. Hence, they are used for temporary and unimportant structures. Nextly, we have fourth class bricks. These are the overburnt bricks. They are dark in color. The shape is irregular. They are used as aggregates for concrete and foundations. Means as they are overburnt, they break up into pieces. Hence cannot be used as block material. But yes, these pieces can be used as a filler or aggregate material in the production of concrete or in the construction of foundations or floors or roads. And the last is, let us discuss about the uses of bricks. Bricks are used in different sectors in the construction field. The initial and the foremost is as the building blocks for lining. Lining means covering, you can say, for lining of ovens, furnace or chimneys. Furnaces, ovens or chimneys are the high temperature equipments. Hence, we need to stop the temperature coming out and affecting others. Hence, the surfaces where these are installed can be covered with the brick area. Hence, here I have used the term lining of ovens. For protecting steel columns against fire, the steel columns can be protected by a layer of brick around them so that they do not catch fire or get affected by fire. Nextly, they can be used as aggregates. In our coming lectures, we will be discussing about our next topic, that would be masonry, in which I'll be teaching you brick masonry and stone masonry. Thank you, dear students.